So by using the prime meridian and the equator, we can divide the Earth into four hemispheres. Since the equator divides it into northern and southern hemisphere, and the prime meridian divides it into eastern and western one. So, like we see over here, any location north of the equator is north latitude, and it comes under the northern hemisphere. And any location to the south of the equator is southern latitude and southern hemisphere. Similarly, any location west of the prime meridian is west longitude uh, in this place. And then we have any location to the east of the prime meridian is east longitude. So by combining latitude and longitude, any location on the surface of the earth can be pinpointed. And you can see this as well on Google Map. So click on any location, random location, and it will give you two coordinates, latitude first and then the longitude. And if you change location, and the two will keep on changing and they will follow the same pattern. So from the equator, the latitude will be 0, and above and below it will keep on increasing. And on these lines, it will be the angles which are shown or represented over here. And then you need the other coordinate in order to pinpoint the location, and then comes in the longitude, which is 0 at the prime meridian and 180 degrees at the opposite side. And between we have the angle increasing from 0 up till 180. So by combining the two, we can pinpoint any location on the surface of the earth. So if you see this point A, so it is at in northern hemisphere and in the western hemisphere. So we have 60 degrees north and 30 degrees west. Similarly, the point C would be at 75 degrees south and 75 degrees east. So the method of writing them down is that latitude is always written first, and it must always include north or south sign with it. Similarly, longitude is written second, and it must include east or west sign with it, and the two combined can give you the exact location. So this is a quick exercise. So see if you can locate these points roughly, and by using the two, you can locate any location. So these would be the angles for latitude, and these would be the angles for the longitude. So now let's take that discussion further to our computations of traverse and balancing a traverse. So determining latitude and departure. So first, let's try to understand what is latitude and departure. So latitude is the north-south component of a line, and departure is the east-west component of a line. So like we did before, latitude represents the north-south component, and the longitude word is replaced by departure, and it gives you the east-west component. So these are basically orthographic projections of a line. So let's say we have a survey line AB, and if you draw the orthographic projections, so it would be these two projections, and these are represented with as latitude and departure. So the latitude of the line AB is north. So if you draw the reference at the point A, so the y component or the north-south component lies in the northern quadrant. And for the line CD, again, if you draw the origin at the point C, now it lies in south. And the departure for AB lies in east, and the departure for CD lies in west. Now, in order to calculate their values, what we need is for latitude, we multiply the length of the line by cos of the angle, and we'll get to that bit what this angle is. The angle basically represents the direction of the line, and departure is length times sine of the direction or the angle. And the angle can be either a bearing angle or azimuth angle. So first we need to understand why this angle is there. So like we discussed before, that in traverse we have one component which is the linear measurement length, and we have the other component which is the angle. And the angle is there to ascertain the direction of different survey lines. Now that direction of survey lines is usually taken uh, in global terms from the north, and from the north that is called as azimuth. but you don't always have to take it from the north. So what we are trying to do over here is that we are trying to balance the traverse or check if the traverse is geometrically accurate by calculating the latitudes and departures of all the lines. And in order to calculate the latitude and departure of all the lines, you need a reference. And that reference can be north in terms of azimuth. It can be bearings from the north or the south. So they would be from 0 to 90 degrees, or the azimuth would be from 0 to 360 degrees, or you can set any direction, one reference direction from where all the other angles or other directions will be ascertained. So that reference is important. North is not that important. Over here, we are going to use north because that is usually the basic reference direction. But if I have a traverse A, B, C, D, E, and A, I can set any line as my direction. And then from that same reference direction, I'll calculate all the other angles. So basically, that would become my north. I am giving north a new direction. So after that, you just multiply the length of the survey line by its cos and sine with the angle. So that gives you the projections. So a linear measurement of latitude and a linear measurement for departure. But what we have to understand is that, like in latitudes and longitudes, the latitude over here is positive in the northern hemisphere or in the northern quadrants, and it is negative in the southern quadrants. Similarly, the departure is positive in the eastern quadrants and it is negative in the western quadrants. So, based on which quadrant the line points towards, it can have different signs for latitude and departure. Now, if you are using the whole circle bearing, that means you are using azimuths from the north. The angle value itself, when plugged into these two equations, will take care of the final sign for latitude and departure. But if you are working with some other reference, or if you're working with the bearings from the north or south, so if you remember, the bearings are either from the north or from the south, and they are always from 0 to 90 degrees. And sine and cos are positive from 0 to 90 degrees. So in that case, you have to give them the sign yourself. So if the line lies in the northeast, latitude and departure would both be positive. If it lies in the northwest, latitude would be positive and departure would be negative. If it lies in southwest, both would be negative. So depending on which quadrant it is, you have to give the sign yourself to these equations. But if you're using the whole circle, then the sign would be automatically there. Now let's see these two lines. So in the traverse case, what is important is your direction of survey. So if I'm going from A to B and then from B to C, C to D, D to A, so I'll have the same reference, the direction of the survey lines. Uh, you just set one direction and then stick with it, and then all the calculations that you do will be accurate. So let's see these two lines. First, we see the line AB, and from the north, this is the azimuth, and whatever it is, you replace in the equation, and it will give you the values of latitude and departure. So since this lies in northeast, so both will be positive. Now for the second case, CD, it lies in southwest. So that means in our case, both will be negative. So you just replace the azimuth in the equation, multiply it with the length, and then it will give you the departure value if you multiply it with the sine, and the latitude value if you multiply it with the cosine. So a bearing of south 47 degrees 35 minutes east has a negative latitude because it's south, and a positive departure because it's east. So let's see two more examples. So in the first case, we have survey line DE, and it is the, as you can see over here, it is not the azimuth, it is the bearing, because it is anti-clockwise. So in order to calculate that, we'll have the length, which is 352.2 feet, multiplied by for latitude cos into 25 degrees 35 minutes, and you get this. Now, since it is in the north, so this will be positive. Now, for the departure, the bearing remains the same, the length remains the same. You just multiply it with sine, and in this case, it is in west, so this will be negative over here. This is a typo, so this will be negative 152.1. Similarly, for this line MR, so the azimuth is given 232 degrees 50 minutes, and you multiply the length of this line by cos and sine of that azimuth. When you multiply it with cos, you get the latitude, which is negative 156.6. So the benefit of working with the azimuth is you get the sine automatically. But if you just see it lies in south, so this should have been negative. Similarly, departure should have been negative because it is west. So two more examples. The line AB. So it lies in the northeast. So latitude AB is north and departure AB is east. But like I discussed before, it all depends on your direction of survey. So if you have a closed survey, you can either go in this direction or you can go in the reverse. So the same line AB, which had a positive latitude and a positive departure, if you reverse the line, you get a negative latitude and negative departure because now the north quadrant becomes the south and east becomes the west. So by reversing it, the value remains the same, but what happens is that the signs are reversed because the quadrants are reversed. So you just have to pick one direction of survey and stick with it for your entire work. So now let's talk about the errors in closure. So when you're working with a closed traverse, when you calculate latitudes and departures for all the lines, the summation of all the latitudes has to be equal to 0 and the summation of all the departures has to be equal to 0. Since we are working with closed traverse, so the latitudes and departures give you the projections in terms of north-south and east-west. Since it's a closed traverse and when you start from A, the traverse gets back to A, so whatever distance that you cover in the north, the same distance you cover in the south. So that is why the summation of the latitudes and the summations of departures equal to 0 because we are forming a closed loop. Whatever distance you cover towards the east, the same distance you cover towards the west, and it should be equal to 0. You can either do this by in terms of giving reference coordinates or coordinates from starting from A, or you can have some other coordinate system. Still, the summation of the latitudes and the summation of departures has to be equal to 0 as long as you're working with a closed traverse. And if this is not equal to 0, then it means that there is some error which needs correction. So in this way, instead of dealing with the uh, errors in angles and distance measurement separately, uh, especially for the distance measurement because we didn't have any specific method to solve for the error in apart from measuring the distance again and again or applying different corrections if you're using tape. So all the tedious work is everything is ignored if you use this method. So once you have the traverse, once you have the angles and the lengths, you just perform the computations since the latitude takes care of length and the direction, the angle, and the departure does the same. So this method takes care of corrections in linear measurements and the angular measurements.